Box plots. We will explain box plots with the help of data from an in-class experiment. Students in introductory statistics were presented with a page containing 30 colored rectangles. Their task was to name the colors as quickly as possible, and their times were recorded. Here is an example of the colored rectangles that the introductory statistics students viewed and named as quickly as possible. We'll compare the scores for the 16 men and 31 women who participated in the experiment by making separate box plots for each gender. Such a display is said to involve parallel box plots. There are several steps in constructing a box plot. First, we draw the y-axis. Then we draw lines representing the 25th and 75th percentiles for each gender. Thus, for each gender, the lower line is the 25th percentile and the upper line is the 75th percentile. For the woman, the 25th percentile is 17 and the 75th percentile is 20. For men, the 25th percentile is 19 and the 75th percentile is 25.75. We can see already that it took men longer than women to name the colors since both percentiles are higher for the men than for the women. The next step is to conduct the lines forming boxes for each gender. Now we draw a line showing the median for each group. Naturally, the median is between the 25th and the 75th percentiles. The median time is 19.5 for the woman and 22.5 for the men. Some terminology is helpful for explaining more about box plots. The upper hinge is the 75th percentile, the lower hinge is the 25th percentile. The h-spread is the difference between the upper and the lower hinges. For the woman's data, the upper hinge is 20, the lower hinge is 17, and the h-spread is 20 minus 17, which is 3. Here we have three more important terms. A step is 1.5 times the h-spread. There are two inner fences. The upper inner fence is one step above the upper hinge. The lower inner fence is one step below the lower hinge. For the woman, a step is 1.5 times the h-spread of 3 and equals 4.5. Recall that the upper hinge is 20. Therefore, the upper inner fence is 20 plus 45, which is 24.5. The lower hinge is 17. Therefore, the lower inner fence is 17 minus 45, which is 12.5. The outer fences are 2 steps above the upper hinge and 2 steps below the lower hinge. The upper outer fence is 20 plus 2 times 44.5, which equals 29. The lower outer fence is 17 minus 2 times 4.5, which equals 8. Just a little more terminology and we will get back to the drawing the box plot. The upper adjacent value is the largest value below the upper inner fence. If you recall, the upper inner fence is 24.5. Looking at the raw data, you can see that the highest value below 24.5 is equal to 24. Therefore, the upper adjacent value is 24. Similarly, the lower adjacent value is the lowest value above the lower inner fence. The lower inner fence is 12.5, and the lowest value in the data above, 12.5, is 14. Note that it is not uncommon for an adjacent value to be the lowest value in the data. Now that we have gone through all the terminologies, we can continue drawing the box plots. The next step is to draw the whiskers. Whiskers are vertical lines that end in a horizontal stroke. A whisker is drawn from the upper hinge, which you recall is the 75th percentile, to the upper adjacent value. A whisker is also drawn from the lower hinge, the 25th percentile, to the lower adjacent value. The upper adjacent value for woman is 24. You can see that the whisker extends from the 75th percentile of 20 to be upper adjacent value of 24. Similarly, a second whisker is drawn from the 25th percentile of 17 to the lower adjacent value of 14. To review, one whisker is drawn from the upper hinge to the upper adjacent value. The other whisker is drawn from the lower hinge to the lower adjacent value. An outside value is defined as a value beyond the inner fence but not beyond the outer fence. For the woman, the upper inner fence is 24.5 and the upper outer fence is 29. Notice that there is one value that meets this criteria, 29. This value of 29 is therefore an outside value. Outside values are indicated by small o's. Values that are beyond the outer fence are called far-out values. These far-out values are marked as asterisks. We have no far-out values in these data. There is one more mark to include in box plots, although sometimes it is omitted. We indicate the mean score for the group by inserting a plus sign. This figure provides a revealing summary of the data. Since half of the scores in a distribution are between the hinges, recall that the hinges are the 25th and the 75th percentiles, we see that half of the women's times are between 17 and 20, whereas half of the men's times are between 19 and 25. We also see that women generally named the colors faster than the men did. Although one woman was slower than almost all of the men, we also see that the median time for a woman is pretty close to the 25th percentile for men. This indicates that a woman who is slower than half of the women would be slower than only about 25% of the men. Here we see the box plot for the woman with detail labels.